Welcome to Electrical Diagrams in preparation for lab number 1. After watching this video, you will be able to identify some of the common drawings used in the electrical industry, explain the difference between a schematic diagram and a wiring diagram, explain the importance of drawing standards when creating electrical diagrams, identify basic schematic symbols and how they are drawn, and finally, you will be able to prepare schematic and wiring diagrams required for lab number 1. Electrical circuits are designed and constructed in accordance with electrical diagrams. These diagrams vary in type. However, they all have the same purpose: to communicate circuit details and specifications among the different personnel responsible for the design, construction, use, operation, and maintenance of those circuits. Technologists troubleshoot, test, and design electric circuits and systems. Electrical diagrams are an extremely important tool for engineering technologists, and it is essential that you are able to draw and interpret them correctly. The most commonly used electrical diagrams are schematic or elementary diagrams, connection or wiring diagrams, terminal and connection diagrams, single line diagrams, and riser diagrams. Schematic and wiring diagrams will be used extensively throughout this course. The schematic is normally used to design a circuit from a written or verbal description. It shows the order of the components making up the circuit and the operational sequence of the circuit. It does not show the actual physical location of the equipment or actual wire destinations and connection points. Schematics are great for troubleshooting circuits. A connection or wiring diagram displays the relative physical arrangement of components, including all wiring and connections. The physical relationships and positioning often make it difficult to determine the actual electrical operations and relationships. The wiring diagram shows the physical connections for the schematic diagram. When it comes to the construction of the circuit, the actual equipment layout and wiring should be identical to the wiring blueprint. If it works on paper, it should work in the field, providing the circuit has been constructed exactly as per the wiring diagram. The schematic and wiring diagram shown are of a non-reversing full voltage motor starter. To illustrate the difference between the schematic and wiring diagrams, let's look at the fusible disconnect switch in the wiring diagram. We can see how it is wired and what the physical equipment looks like. The schematic shows us the components that make up the disconnect switch, as well as how they are interconnected with one another. Let's take a look at an example of real equipment installed in the field. In this schematic, you can see the electrical relationship between circuit breaker 101 and contactor 101. They are in series. Here is a photo of the completed installation. You can see the physical location of circuit breaker 101 and contactor 101. It's pretty hard to tell from the installation photo that these two devices are in series as shown on the schematic. The schematic does not give any indication of the physical location of the equipment. Here is a look at the same photo alongside the wiring diagram for the circuit breaker and contactor. Notice how the wiring diagram shows details of the equipment as well as their physical locations. Schematic and wiring diagrams are drawn using standards. Standards make sure drawings are created consistently across organizations so that everyone is interpreting the same information. If you are drawing diagrams by hand, you must use a pencil, straight edge, and template. We prefer you use a computer drafting program like AutoCAD. All lines need to be drawn horizontal and vertical in both the schematic and wiring diagrams. IEEE Standard 315/1975 provides a list of standardized symbols used in creating schematic diagrams. A copy of the standard is in your D2L course content. Notice the equal spacing between the three-phase conductors in this schematic. Nodes or junctions are allowed on a schematic diagram to show the interconnection of devices. Nodes are not allowed on a wiring diagram. A wiring diagram shows all connections from one terminal to the next. When two conductors need to connect to the same terminal, slight angles may be used to accommodate both wires. Notice there are no nodes on the wiring diagram. When conductors need to cross, simply draw straight through them. Equipment, devices, terminals, and conductors need to be labeled to properly identify them. Remember, When it comes to the construction of the circuit, the actual equipment layout and wiring should be identical to the wiring blueprint. If it works on paper, it should work in the field. The following slides are going to show a few of the electrical symbols we will use in this course and in your first experiment. Other symbols will be introduced as required. You should already be familiar with these from your prerequisite courses. Notice the difference between a fixed and variable source. An arrow is drawn through the source to represent that it can be varied. If you need to show a variable inductor or capacitor, draw an arrow through it similar to the variable resistance. Another way to draw sources that represent the power supplies is to draw terminals and then label them with the appropriate voltage and polarity. This is often preferred as it saves time and is simpler to draw. Single-phase fixed and variable AC sources can be drawn using the schematic symbols or as terminals. Make sure to label the voltage as fixed or variable. The best way to draw fixed and variable three-phase sources is to draw terminals and label them with the appropriate phases and voltages. The fixed source is an example of a three-phase, three-wire supply, and the variable source is an example of a three-phase, four-wire supply. When you are measuring only voltage or current, you can use the standard symbols for voltmeter and ammeter. When it comes to measuring power, you need to draw a wattmeter. This example shows a wattmeter that can be used on either a DC or single-phase AC circuit. The single-phase wattmeter has a current coil or element and a voltage coil or element. In lab number 1, you will be connecting 2 or 3 wattmeters to measure three-phase power. The 2 wattmeter method shown here can be used to measure power in a three-phase circuit. It is extremely important that the polarity of all coils are connected as shown and that the current and voltage inputs I1E1 and I2E2 are used on the lab volt data acquisition interface. The total circuit three-phase power will not be measured if the meters are not correctly connected. In order to draw a schematic diagram from a description, you first need to make sure you use the correct schematic symbols to represent the circuit components you need to draw. Let's do an example similar to the first circuit you draw in lab number 1. Here the description says, draw the complete schematic diagram of a 300 ohm resistive load connected to a 120 volt DC fixed source. Connect the metering required from the DACI module to measure the current through the resistive load as well as the voltage across it. Use E1 for voltage and I1 along with the 4 amp input to measure current. Show instrumentation on your schematic. Sometimes the description contains information that is not relevant to creating the schematic diagram, but it is essential information for creating the wiring diagram and building the circuit. The description for our circuit says to use E1 and I1 along with the 4 amp input to measure current. This information provides us with details as to the connections of the actual physical meters, so it is important when we create the wiring diagram that the 4 amp current input is used. Labeling is extremely important when it comes to electrical diagrams. Notice the source voltage is labeled, the load is labeled, and the meters are labeled along with their polarity. Polarity is extremely important when connecting metering and instrumentation. Once the schematic is designed, a wiring diagram can be created before constructing the circuit. Always build your circuit from a wiring diagram. In large circuits, sometimes you may find it easier to draw the wiring diagram if you highlight or mark the parts of the schematic that you have completed. To start, I'm going to draw the wire that is connected from the positive of the DC source to the positive 4 amp input of meter I1. I will highlight this connection and then draw it on my wiring diagram. I will follow the same process for the rest of the connections. When it comes to metering, it's good practice to draw the ammeter circuit first, then add your voltmeter last, as a voltmeter is simply in parallel with what you want to measure. I already have my ammeter in the circuit, so I will add the voltmeter last. Don't forget the 24 volt supply for your instrumentation, as well as the USB connection to your PC. Even though these are not shown on your schematic, you will need them in every circuit you build. Notice the horizontal and vertical lines. There are no nodes on the wiring diagram, and slight angles are used to go into and out of terminals in which more than one wire is connected. Try not to clutter your diagram, group wires together, and the most important thing, do not draw through terminals when trying to go from one location to another. That wraps up electrical diagrams. A few things to remember: always draw a schematic and wiring diagram for every circuit you're going to construct. Make sure to use the correct schematic symbols. Pay attention to the polarity of sources and meters. If drawing by hand, use a pencil, straight edge, and template. Remember, if it works on paper, it should work in the field.